Hello, good morning. Today we will discuss about information rate and some example related to information rate. We can represent the information rate by capital R. Here R is equal to small r and capital H. H is average information, or we can say entropy. We teach in my previous slides or lecture, and small r is rate at which messages are generated. It is also called rate of source, means how many bits required for message per second we can transmit. So we can calculate capital R is equal to R in message per second and H in information bit per message. We can cut the message by message, and information rate is equal to information bit per second, means how many information transmit per second. We use a small example for understanding the concept of information rate. Simple example, a analog signal is band limited to B hertz, means bandwidth is B, and sample at Nyquist rate, means B sample by Nyquist rate means it is equal to 2B. The samples are quantized into 4 label, means here 4 messages or 4 label for particular message. Each label represents one message. Thus, there are 4 messages. The probability of occurrence of these 4 labels are here P1 and P4 is same as 1.1 upon 8, and P2 and P3 is same again 3 upon 8. Total probability is equal to P is 1. Then find out the information rate of source. If all messages and if all messages are equally likely, comments on the result you obtain. So simply first we calculate the entropy, and we have 4 messages with probability P1 P4, and P1 P2 is equal again 1 upon 8, and P2 and P3 again equal is 3 upon 8. Total average information means information average information H is equal to entropy is the summation of pk log 2 and 1 upon pk. Here we have 4 messages, so pk is 1, p1 p2 p3 p4. Here p1 log 2 1 upon p1, and this formula used in my previous lecture, plus p2 log 2 base 1 upon p2 plus p3 log 2 1 upon p3 plus p4 log 2 1 upon p4. Here put all the values. Here p1 is 1 upon 8, and p2 is 3 upon 8, and p3 again 3 upon 8, and p4 is 1 upon 8. Put all these value here. Calculate the entropy. H is equal to 1 upon 1.8 bits per message, means average information for message is 1.8 bit. Then calculate the message rate, means small r. Here the bandwidth is B, and in Nyquist rate is 2B sample per second. So R is 2B message per second, because every sample generate one message signal. So 2B sample per second is equal to 2B messages per second. Then calculate the information rate R is R again is equal to small r into h, put the all both value, and r is equal to 2b and h is equal to 1.8. Here uh, information rate is equal to 3.6 b bit per second. In this example we discuss four label of message, and so these four label can be coded using binary PCM. Here Q1, Q2, Q3 and Q4, these are the basic messages and probability is 1 upon 8, 3 upon 8, 3 upon 8, 1 upon 8. So we can use the binary digit here. We use 4 bits and we use 4 label and we use only 2 bits is 00, 01, 10, and Q4 is 1 upon 8, probability is 1 1. Two binary digits binit are required to send each message. So messages are sent at the rate of 2b message per second. The transmission rate of binary digit will be is equal to 2 binary per message multiplied by 2b message per second. So here binary rate is equal to 4b binaries per second. Means one binet is capable for conveying 1 bit of information. Above coding scheme is capable of conveying 4 bit of information per second, but from the example we are transmitting 3.6 bit of information per second. This show that information carrying capability of binary PCM is not completely utilized by the transmission scheme. So this situation we will improve in next section. Here we use 4 messages and they are equally likely, means equal probability. If probability total sending message is 1 and we have used 4 messages and the single probability of per message is equal to 1 upon 4, so p1 p2 p3 p4 is again is equal to 1 upon 4. Put all the value in entropy formula, in H is equal to summation of pk log to 1 upon pk. Here pk is p1 p2 p3 and p4, and put the all the value, and this entropy is equal to 2 bits per message. And again r is from the example is 2b message per second. So capital R means information rate is equal to 4 bits per second. So we have seen that binary coded PCM with 2 binary per message is capable of conveying 4-bit message of information per second. The transmission scheme we will discuss in this example. Transmit 4b bits of information per second means all messages are equally likely. Binary PCM coding, the maximum information rate is achieved if all messages are equally likely. So we use all the conditions of the